Every graph has key features. Intercepts peaks and low points. Read them to know it.
Welcome back to the salmon run. A mathematical function's symbolic rule is like a description of a river you haven't seen yet. Graphing is the act of drawing that river so its overall shape becomes plain. You're mapping the path so the bends and reaches are no longer a mystery. You can sketch the gentle, predictable stretches of the water by hand, but for the tangled, complex rapids, you let a tool render the graph. You can read its structure, predict its shape, and answer questions. Take the rule y equals x squared minus 1. When we aren't sure where the path leads, our baseline move is to test individual points along the way. This table organizes our search. We choose inputs from -2 to +2. Calculating each output shows a pattern: 3, 0, -1, 0, and 3. Plotting these pairs reveals the function's hidden profile, drawing a smooth, U-shaped parabola. The table method is a reliable way to make the invisible visible, but computing every single point manually can be a slow, tedious process. We can work faster by looking at how the math is arranged. For y equals the quantity x minus 4 squared plus 2, the structure itself suggests a shortcut. Vertex form points directly to the most important landmark, the vertex at 4, 2. It also reveals a perfectly balanced axis of symmetry at x equals 4. These features anchor our sketch accurately, bypassing a long list of extra points. Reading the algebraic form acts as a guide, letting us bypass the manual work and get straight to the shape. In a simple linear case like y equals 2x plus 1, we only need the absolute minimum of evidence to find our way. A straight line is determined by just 2 points. We start with the y-intercept at 0, 1. Using a slope of 2, we move up 2 and right 1 to 1, 3. Connecting them completes the map of the function. When the rule is simple, we can translate it into a graph using only a few well-chosen features. Sometimes, however, the symbolic rule is so tangled that sketching it by hand becomes impossible. This is when we use graphing technology to instantly render the curve for us. Even when a machine does the drawing, we still have to decide where to look. This window shows how we shift the focus to capture the most important behaviors, like the peaks and the intercepts. The technology handles the raw computation, but we still have to direct the investigation. Every algebraic rule is a structural blueprint for a visual shape. The expression itself tells you exactly where to look for important features. Learning to find these features helps you predict how a graph will behave and understand how different functions compare to one another. Before you start plotting, look closely at the function's structure and let its arrangement reveal the path ahead.
Where it crosses the axes. The turning points are extremes. T features reveal the shape.